Alrighty, so here is the key to that salmon review. Remember, the blue one will be in Schoology. So we're going to plot the following on the polar grid and label with the problem number. So the negative 135 degrees, remember we're going to find the angle first. So I'm going negative 135, so this is 90 and then another 45. So here's the angle. I'm somewhere on here and my radius is 1, so it's this point right here, and that is number 1. Alright, so then 2, negative 270. So negative 270 is going to be, this is negative 180, and then that's negative 270. My radius is 2. That is number 2. Number 3 is 210 degrees. And then, or negative 3, 210. So I'm going to go a positive 210. So this is 180, and then another 30. So I'm here. Okay, but it's a negative 3, so I go through the pole. 1, 2, 3, and this is number 3. 4 is going to be 4 pi thirds, so I go a positive 4 pi thirds, so this is 1, 2, 3, 4 pi thirds, and my radius is 4, 1, 2, 3, 4. Then I have negative 5 pi fourths, so start here. This is negative 4 pi fourths, so this is negative 5 pi fourths, and it's a negative 5, so I go through the pole, 1, 2, 3, 4, 5, and that's number 5. Alrighty. Now to find the alternate points, polar coordinates for the given points. Remember, there's actually an infinite number of answers, but we're going to just give them from negative 2 pi to 2 pi. So it's a good idea to have in your mind where the point actually is. So even though this is it's like a polar grid, I'm not going to draw the little circles because it would look horrific. But 225 degrees I know is going to be in the 3rd quadrant, and 6, so it's like somewhere over there. Doesn't even matter, just so you kind of have an idea of what's going on. So your 3 alternate ordered pairs. You're going to have, if this is a positive 6, you're going to have another one that's a positive 6, and 2 that are negative 6s. And this is positive, positive. So this one's going to have to be positive, negative. This one could be negative, positive, and then negative, negative. Okay, so you've got to have one of each of those. So to get to this point, and my radius still be 6, instead of a positive 225, I could go a negative 135 and get to the same spot. If it's going to be, my radius is a negative 6, to end up here, I would have, my angle would have to be in the 1st quadrant, and then my negative 6 would go through the pole. So to get here in the 1st quadrant, to have a positive angle, that would be a positive 45 degrees, or a negative 315. So then here, this negative 5 pi sixths is going to end up also in the 3rd quadrant, because this would be 6 pi 6, so I have to be here somewhere. My radius is 8. So I'm going to end up with, this is positive, negative, so this is going to have to be positive, positive, and then these are both negative. It doesn't matter what order you do them in, but if you kind of line it out, maybe you won't forget something. This can be negative, positive, and then that can be negative, negative. All right, so to get here, instead of going a negative 5 pi sixths, I could go a positive 7 pi sixths. Oh, I don't know why I just made that negative. I was trying to make a 7. Said one thing and wrote another. All right, positive 7 pi sixths. Or negative 8 would end up over here. Okay. Or at negative 8, I would get my angle to here and then go negative in through the pole. So that would be a positive pi sixths or a negative 11 pi sixths. So those are my alternate answers there. All right, so matching for 8 through 11, your radius is, remember, r squared equals x squared plus y squared, so r is the square root of that, so that is c. To find theta, theta is always the tangent inverse if x is positive. If x is negative, you have to add pi or 180, so that's a. X is our cosine theta, and y is r sine theta. Oops, I was about to put y, but that's really b. All right, so matching. An answer may be used more than once, and in addition to that, there's a lot more letters than there are numbers, so not all of these match over here. So we can start with, okay, we've got theta equals 75 degrees. Well, that's not a special angle, and let's see, that's not a circle. Okay, this would be a line. So it would be a line through the origin. Well, at 75 degrees would make my angle up here, so my line would look something like this. So it is a line through the origin, we know that. It does have a positive slope, not a negative slope, but let's read the rest of them. It's not a circle, not a circle, not a circle. It's not the line x equals 5 or y equals 5, because that would be vertical, that would be horizontal, and same thing there. So the only one that makes sense here is B. So r equals 5, that is a circle, okay, and the radius is 5. So this says circles, and it would be a circle centered at the origin or at the pole. So circle centered at 0, 0, that sounds good. Radius of 25, no. That's not that radius. It clearly says right there, radius is 5. Line through the origin, it's not a line. Circle centered at 0, 0 with radius 5. Pretty sure it's this one. That one sounds good. Circle, center, nope, because the center's at the origin, nope. And then those are all lines, so my answer has to be D. All right, so then this is a circle. It is centered at the origin, and the radius is 5. Well, we just chose that one, D. We chose it here. Well, it makes sense for both of them, and it says an answer may be used more than once, and that's in bold, so I'm saying my answer is D again. Theta equals 0. This is a line, okay? That line, theta equals 0, means theta is always 0, so it's this line right here. So then it takes you having to understand Algebra 1 and know, is it the line y equals 0 or x equals 0? Well, it is the x-axis, but it is a horizontal line, so it is y equals 0, which is I. Okay, then r cosine theta equals 5. Well, r cosine theta is x, so x equals 5. That is this right here, g. r equals 10 cosine theta. All right, well, I don't get to just substitute something in there, so I got to do a little bit of work here. This is r squared equals 10r cosine theta. So x squared plus y squared equals 10x. So I know it's a circle. Not going to be one of my line answers. And once I start to simplify this, x squared minus 10x, then I'm going to have to do plus 25. Plus y squared equals 25. Right? So still my radius here is 5. It's not 25, so still don't like A. But it's not centered at the origin. When I actually write this out, I get x minus 5 squared plus y squared equals 25. So it's centered at positive 5, 0. So my answer is E. And then the other ones just don't fit over there. All right, so I'm going to find the polar coordinates. And I think some of you are getting the whole converting coordinates and converting equations a little mixed up. You're still kind of substituting some of the same stuff, but I mean, it's the same processes and same pieces that you're using, but we're doing it a little different because our answer here is going to be a point, not an equation. So if I want to find the polar coordinates, that means instead of it being in an xy form, it has to be in r theta form. Okay? So I have to find r. This right here is in xy form. Well, r is equal to the square root of x squared plus y squared, and then theta is the tangent inverse of y over x. But if you have a point that is on an axis, which if x or y is 0, your point is on the axis, you can actually come up with your answer pretty easily without doing a whole lot of work. Because here's your point, right? Negative 7, 0. Your point is over here. Well, I need this answer to be in r theta. Well, the theta here, and it says to do this in degrees, is 180. And your radius then would be 7. So there you go. You can do the work. The work behind it would be that you would do r equals the square root of negative 7 squared plus 0 squared. And in the end, you're going to get 7. Okay? And then your tangent inverse of y over x, 0 over negative 7. Right? That's going to give you the tangent inverse of 0. So your answer is either at 0 or it is at 180. But since your x is negative, you have to add that 180, and then there's your answer right there. So, but again, you don't even have to go through all this because you know exactly where it is. So here, 0, 5, bam, there's my point. So the radius is 5, and your angle is, oh, I was going to do it in radians, is 90. Okay, so the next two don't really work out that way. I've got to actually find the pieces here. So r is equal to the square root of 4 squared plus negative 3 squared. Plus this would make it a 3, 4, 5 triangle if you recognize that. But that's 16 plus 9, which is 25. Square root of 25 is 5. So your radius is 5. Your angle, the tangent inverse of negative 3 over 4. So that you're going to have to use the calculator for. And I want it in degrees because that's what the directions say. So mode. I want it back in. I'm just going to do all this and make sure it's in degrees. I could have just reset it, but it changes how dark it is too on mine. All right, so now I'm going to do tangent inverse of negative 3 divided by 4. So it gives me negative 36.869897, blah, blah, blah. Okay, so let's just think about where this point actually is. It's not on an axis, but 4, negative 3 is down here in the 4th quadrant. Well, this angle is in the 4th quadrant, but we usually like them to be positive, so I'm going to add the 360 so I get the positive version. Both of these are in the 4th quadrant. I would take either one because there's not really a hard and fast rule because there's actually an infinite number of answers here, but I'm just going to write down the positive one. So we get 320, actually I probably shouldn't have put it, I'm going to write too big, so 323.130 degrees. All right, so then I'm going to do on 21, same sort of thing. R is equal to the square root of negative 25 squared plus 10 squared. So that's going to be 625 plus 100, so it's the square root of 725. Okay. So if you have 725, I'm going to divide by 25 to try and simplify it. So if I have $7.25, think about how many quarters you would have. You'd have 29. So I could simplify this to 25 and 29. So that means that would give me 5 square root of 29 for my radius. 5 square root, oops, not a comma, not a comma. Goodness. 5 square root of 29. Comma goes here. So then I have to take the tangent inverse of 10 over a negative 25. But since x is negative, I have to add 180. Let's look at why that happens. My point here at negative 2510 would be somewhere there in the 2nd quadrant. Well, when I go to my calculator and I do the tangent inverse of 10 divided by a negative 25, I get this angle, which is a 4th quadrant angle. And that is, when I had that here, whether it was positive or negative, the number the calculator gave me was fine. It was just the negative version of this. This angle is straight up wrong because I'm not supposed to be in the 4th quadrant. The x was negative, so I have to add the 180. When I do that, I do end up with a 2nd quadrant angle, and that is my answer. And so that is 158.199 degrees. Okay, so that's going from rectangular to polar. So now I'm going to go from polar to rectangular, which means my answers have to end up in XY form. In order to do that, I need to substitute, right? Right now I have R and theta. Instead of R and theta, I'm going to use those to find my X and my y. So my x is r cosine theta, so negative 2 cosine of 270, and my y is r sine theta. Okay, so negative 2 cosine of 270. So I need to know what the cosine of 270 is. Cosine of 270 is 0, so 0 times negative 2 is 0. Okay, this would be expected for you to be able to handle this without a calculator. So then negative 2 times the sine of 270. Sine of 270 is negative 1, so negative 1 times negative 2 is a positive 2. And so if we were to plot this point, 270 with a negative 2 radius, I go to 270, go through the pole 2, there's my point. Well, that's the point 0, 2. So again, you could have come up with that maybe without doing this, but sometimes this has to be done if it's not on an axis. Now, the next three have to be done with a calculator just by the nature of what's been given to you, but you could be given special angles on here and be expected to do it without a calculator, so make sure that you can do that as well. So what I'm going to do here is this is going to be 7 cosine of 3.3, 7 sine of 3.3. All right, well, is that degrees or radians? Well, it doesn't have a degree sign. These two do. These two do not. So they are both in radians. So I need to make sure that my calculator is in radians. So that means I'm going to do 7 times the cosine of 3.3 and 7 times the sine of 3.3. So there are my two answers, both of them to the nearest thousandths, always. This is going to give me negative 6.912 and negative 1.104. Same exact process for the next two. So 6 times the cosine of negative 156 and 6 times the sine of negative 156. Now here, let me back up just a second because you can think about where this point is as well. 3.3, well, I know that pi is 3.14, so 3.3 is somewhere down here with my radius of 7, and when I have this point, that's negative 7, negative 1, makes sense. This point here, a negative 156 degrees, is going to give me in the third quadrant with some radius. So I know that my point, again, needs to be negative, negative. That's the answer I should expect here. So I'm going to go back to my calculator. This time this is in degrees, so I got to make sure I'm in degree mode. And then I'm going to get 6 times the cosine of negative 156 and 6 times the sine of negative 156. Okay, so those are that's my x and y value. It's negative, negative like I expected. So that gives me negative 5.481 and negative 2.440. 25. Negative 3 cosine of 5 pi sevenths, negative 3 sine of 5 pi sevenths. So this point here, 5 pi sevenths is going to be in the second quadrant. Negative 3 radius will give me in the fourth quadrant. So I should expect my answer to be positive x, negative y. 5 pi sevenths is not a special angle, so I'm going to use my calculator, but I need to be in radian mode again. Back and forth, back and forth. I'm going to clear my calculator so I can see this. So negative 3 cosine of 5 pi sevenths, negative 3 sine of 5 pi sevenths. There's my two answers. It's positive, negative like I expected. Of course, that doesn't guarantee me that I'm 100% right, but I would know I was wrong if that didn't happen. And here is what I get. Okay. Now remember, these you can expect to need to have to do in exact form as well. Same thing up here. So make sure that you still have to know your unit circle. All right. On the back. Now I know most of you, probably all of you, did this 100% on the calculator. But again, this is really a non-calculator question because the angles that were given to you, you didn't even have to come up with the numbers to put in your chart. You can find the sine of all of these in exact form. Okay, so we're going to go through and think about them that way. My theta is 0. When I substitute that in here. Well, the sign of 0 is 0. So 0 times 2 plus 2 is 2. 30. The sign of 30 is 1/2. So 1/2 times 2 is 1 plus 2 is 3. 60. The sign of 60 is the square root of 3 over 2. When I substitute that in here, 2 times the square root of 3 over 2 is just the square root of 3. So my R value is actually 2 plus the square root of 3. Then I need to know basically what that is to estimate, so I can go over there and plot that in just a minute. Square root of 3 is about 1.7. So 1.7 plus 2, 3.7 is my estimation. If I was going to write down a decimal, it would need to be to 3 decimal places, but that's just for me to be able to estimate in my head and go over to the graph and get something I can actually plot. 90, the sign of 90 is 1. 1 times 2 is 2 plus 2 is 4. 120, the sign of 120 is square root of 3 over 2, and that is positive. And so square root of 3 over 2 times 2 is the square root of 3 plus 2. It's the same value I get here, so 2 plus the square root of 3, which is about 3.7. 150. So the sign of 150 is 1/2. 1/2 times 2 is 1 plus 2 is 3. 180, the sign of 180 is 0. 0 plus 2 is 2. 210, the sign of 210 is a negative 1/2. So negative 1/2 times 2 is a negative 1 plus 2 is 1. 240, the sign of 240, because we're over here in the third quadrant, and my reference angle is 60. So that's square root of 3 over 2, but it's negative. So negative square root of 3 over 2 times 2 is a negative square root of 3. So this becomes 2 minus the square root of 3. So remember, that's about 1.7. So it's about 0.3 that I would estimate on my graph. 270, the sign of 270 is negative 1. So negative 1 times 2 is a negative 2 plus 2 is 0. 300, sign of 300 is a negative square root of 3 over 2 times 2 is a negative 3. So again, I get 2 minus, square root of 3. 2 minus the square root of 3, which gives me about 0.3. 330, the sign of 330 is negative 1/2. Negative 1/2 times 2 is negative 1. So this gives me 1. The sign of 360 is 0. 0 times 2 is 0 plus 2 is 2. So there are my points that I can go plot. So at 0 degrees, my radius is 2. At 30 degrees, my radius is 3. At 60 degrees, my radius is about 3.7. So 1, 2, 3, 0.7. At 90, it is 4. At 120, it's again about 3.7. At 150, it's 3. At 180, it's 2. At 210, it is 1. At 240, it's about 0.3. 270 at 0. Then I'm back at 0.3. Then I'm here at 1. Then I'm there at 2. So this is the shape of my graph here. And this is a cardioid. Okay, so that is my cardioid. To be able to get that graphed, I did not use a calculator for any of that. Right? You have to be able to process through and be able to estimate some basic stuff. So now we're going to rewrite polar in rectangular form and rectangular in polar form. So remember, if I have an R or a theta or both, then I need to make sure it is in XY form and vice versa. Some of you all kind of got stuck in what you were doing. So R cosine theta equals 7. I have something I can substitute R cosine theta for. It is X, so X equals 7. That's my answer. I can't really do anything else, and it can't get much easier than that. So Y equals negative 9. My Y, I can substitute R sine theta. That equals negative 9, and I can't leave it like that. I've got to solve for R. So I could either have R equals negative 9 divided by the sine of theta, or r equals negative 9, and then the reciprocal of sine is cosecant theta. So either one of these. You wouldn't have to have both of them. They are both okay, but I don't want you stopping there. So r equals 8 sine theta. I don't have anything that I can straight up substitute sine theta for. I do for r, but not for sine theta. So I need to make this into r sine theta so that I can actually substitute. So multiply both sides by r, so I get r squared equals 8r sine theta. R squared, I can substitute x squared plus y squared. That's equal to 8, and then r sine theta can be y. So this is going to give me x squared plus y squared minus 8y. Then I need to complete the square, so half of 8 is 4. Square that and I get 16, and I have to add that to both sides. So then I need to put this in binomial form, so x squared plus y minus 4 squared equals 16. So this is a circle. My radius is 4, and my center is at 0, positive 4. Okay? And that's the truth, whether it's rectangular or polar as far as graphing. All right, so my theta equals negative 60. Got it? And it says exact, which means, again, you shouldn't be using calculators if you can get exact answers. It is a line. If it's just a theta equals, it is a line, and it is a line that passes through the pole. So that means what I know is that my negative 60 is down here. My line would look something like this. Okay, so it's going to be a y equals, I've got a negative slope times x with the y-intercept being 0. All it is the tangent inverse of the negative 60. But if you don't see it that way, that's okay, because you can just substitute. Theta gets substituted with tangent inverse of y over x every time. That's equal to a negative 60. So then I take the tangent of both sides, so y over x is equal to the tangent of negative 60. Okay. So 60 is the reference angle. The tangent of 60 is the square root of 3, but the tangent of negative 60, it would be a negative square root of 3. So y over x is equal to negative square root of 3, which means y equals negative square root of 3x. I think that's the exact same question that was on your take-home quiz. All right, so now I have y equals the square root of 3x. So here's what we know about this one. It has a positive slope. It goes through the origin. So in the end, and it's a line, so in the end it's just going to be a theta equals line. And you can do some substitution here, which we'll look at it as substitution. I had to pause, and I don't know what the last thing I said was. So I can do some substitution, but you can just take the tangent inverse of the square root of 3, because the angle is always related to the tangent or the tangent inverse. Like here I had to take the tangent to get the slope, but now I have the slope, so I can take the tangent inverse to get the angle. But again, you don't have to just understand how to plug it in if that confuses you. Substitute. For y, I can substitute r sine theta. That's equal to the square root of 3 times x, which is r cosine theta. So I'm going to divide both sides by r cosine theta, so that'll give me r sine theta divided by r cosine theta is equal to the square root of 3. So the r's cancel out, and this becomes tangent theta, so tangent of theta is equal to the square root of 3. So theta is equal to the tangent inverse of the square root of 3. And so then theta is equal to 60 degrees. Or here it didn't say if it had to be in degrees or radians, so pi thirds also. All right, 32. We have a line that is, I'm sorry, a line. No, that is not a line. We have a circle that is centered at the origin with the radius of 10. So that means in the polar axis, it would be centered at the pole, and the radius would be 10. So it is just r equals 10. But again, if that just doesn't compute to be able to just jump in there like that, that is absolutely fine because you can substitute. X squared plus y squared gets substituted for r squared. That's equal to 100. So that means that r equals 10. You get the same answer either way. Okay. 33. R equals 2 cosecant theta. So r is equal to 2 over sine theta. Right? I don't have anything to substitute for cosecant. I also don't have anything to substitute for sine. But now if I multiply both sides by sine, I'm going to get r sine theta equals 2. R sine theta is y, so y equals 2. And this is how these should have been given to you all along, solved for r. All right, so 34 is given to me in rectangular form. I need it in polar form. So it is the exact opposite process of 29. 29, we have it in polar form, and we have to substitute things to get it into rectangular form. But our steps are going to look pretty much just like this in the opposite way. We work to get it in this form, so I'm going to get it out of this form, and then I'm going to get x squared plus y squared by itself, and just keep working backwards there. So I'm going to go ahead and square this. So this is going to give me x squared minus 4x plus 4 plus y squared equals 4. So on the left, I want to keep x squared plus y squared. I'm going to move everything else over to the right. So it means I'm going to subtract 4 from both sides. Those just go away. I'm going to add 4x, so this becomes a positive 4x. Now I can substitute. X squared plus y squared is r squared. That's equal to 4 times x, which is r cosine theta. Again, if you get lost in, okay, I got this far, what am I supposed to do now? It's in rectangular, you need it in polar. So you're trying to get it to a point where you can actually substitute in the polar forms of things. So now I don't want r squared, I want r, and I can divide both sides by r, so I get r equals 4 cosine theta. Then r equals 7. All right, well, I know what to substitute. So again, you can just kind of understand what that means. It's centered at the origin, and the radius is 7, so you can just write the circle equation, or you can substitute. For r, it's the square root of x squared plus y squared. That is equal to 7. Well, I don't want it to look like this, so I'm going to square both sides, and that gives me x squared plus y squared equals 7. All right, and then let's look at graphing these. So we'll graph 33 first. Y equals 2. So I know it's a horizontal line, and if I was on the rectangular axis, it'd be super easy to graph. Got to think a little bit more here, but I know my radius is 2, right? And so y equals 2. It's going to have to go through here, and it's horizontal. But I need a couple more points so that I can actually draw my line well. The easiest one to take the sine of, right? Because even though this is what I'm graphing on here, I want to think of it in this form because it makes it a little bit easier. So sine, I can either choose, doesn't matter if I do 30, 45, or 60, even though 45 isn't there, but 30 or pi sixths is the easiest thing to take the sine of. So the sine of 30 is 1/2. So 2 divided by 1/2 is 4. So at 30 degrees, my radius is 1, 2, 3, 4. It means over here it's 1, 2, 3, 4. So there are my points that I can use to give me that. Okay, and so that is number 33. So then 34. Going to graph this circle. Well, remember when I gave you forms like this and we went to graph them, we didn't just like look at this and graph it or find a table of values. We actually changed it to rectangular form so it would make more sense for us. In rectangular form, I can look at this and I know that my center is at 2, 0 and my radius is 2. So at 2, 0, this is the same thing as that point right there. Your radius is 2. So here are 2 points. This is actually the center of the circle, and then these are 2 points on the circle. And then in order to get 2 more points, the easiest thing to use here, right, is to use the other point up here, and we can do you can do substitution, or you can do your understanding of special right triangles. If this is 2, and I want 2 up here, but I can't really count like that on the polar grid, this would be 2, 2, and then 2 square root of 2 on the 45, and I know 45 isn't even drawn in there, but 2 square root of 2, so if I'm going to look at pi fourths, right, and then my radius would be 2 square root of 2, that's the point I want to go plot. Square root of 2 is like about 1.4, so this is really about 2.8 is what I'm looking at there. So at 45, or at pi fourths, I'm going to go 2.8-ish right there. And then same thing down here, 2.8-ish. And then I'm just going to do my best to make it look circular, and that is not. If that's my best, that's pretty sad. But yeah, be easier on a piece of paper, I think. Alrighty, so then I need to graph, oh, this is number 34. So then I need to graph number 35, which was a bad choice as usual for me. I didn't want you to graph all of them on here and make it crazy, but there's 35. Anyway, that doesn't really fit. Our radius is 7. And I don't even need it necessarily in rectangular form. This only goes out to 5, so you have to kind of guess. And then it's like a way off, and it's okay. It's really fine. I think I would be amazed if something actually worked out totally perfectly once. And we can't even make the whole circle on here, and that's okay. At least you got the idea and knew that it wouldn't fit, so that's a good thing. And this is 35. So you didn't have to graph the rest of them, but let's just talk about them. 32 would look very similar to this, but the radius would be 10, and I definitely don't have room for that. 31, theta equals 60. So again, I know it doesn't say that you have to graph these, but I'm going to graph some more of them anyway. On 31, theta equals 60, or y equals the square root of 3x. Okay? And so when theta equals 60, that means theta always equals 60. And this is what my line would look like for number 31. For number 30, negative 60, so your negative 60 degrees would be right here. And again, this is a special angle, so you would be expected not to have the decimal version of that, which is what some of y'all had on things. Those special angles you have to leave in exact form, so this would be like 30. And then I think that hopefully gets the idea of all of the different things that you could do, because the rest of them, I don't want to make this picture too crazy, but 29 graphs very similar to 34, and then 28 graphs very similar to 33, but it wouldn't fit on there anyway, and then 27 graphs very similarly to 33 also. It wouldn't fit on there either, but since the radius is 7, your x equals 7, it would be over here. It'd actually be tangent to this circle and be vertical, but I have nothing to go by to actually make it look decent on there. Okay, so there you go. Make sure you know your unit circle, and make sure you're prepared to do some of these with the calculator and without the calculator, and know your basic substitutions, meaning that you know that r is equal to the square root of x squared plus y squared, which again, the other form of that is r squared equals x squared plus y squared. So you could do either one of those. It's really the same thing that you're substituting. And we know that x is equal to r cosine theta, y is equal to r sine theta, and that theta is equal to the tangent inverse of y over x when x is positive, and theta equals the tangent inverse of y over x plus 180 or pi, depending on what form you're in, when you have a negative x. Okay. Basically, if you understand this stuff I just wrote here in blue, you can convert one way or the other, and you should be able to graph these. And remember, when you graph them on the polar grid or the rectangular grid, the pictures or the graphs are exactly the same. It's how you're counting on them. It's just a different way to represent them.